In this video, I'm going to using Godot to generate a Sudoku puzzle like this. Let's start. So first we create a 2D node and rename main. Then we can add some nodes for the grid of Sudoku. So first we add a panel node for each grid, and we can set the color. We can use custom styles, and we can add a style box flat, and then we can change BG color to white, and then we can add the child node to the panel. We can add the label for show the number of this grid, and we can set the center position. Then we can set the rect size to fill this panel, and we can set the custom fonts. We use dynamic font, and then we can choose a font data. The font data you can find in this place, and we can choose a font and drag to Godot, and then we can use this TTF file and drag to font data. Then set the font size to 30, and then we can set the font color using this property, custom colors, and we can check this font color, and then we can test. We can set the text, for example 0. You can see this number is shown, and then we clean it, and we can save this panel node to a scene. Save to a scene, and we save this panel scene. Then we delete it, and then we can add the main script, so we can start to write the code to generate the Sudoku puzzle. And at first we can define some variable. We can define row is 9 and column is 9, and we can define the size of the panel is 40, and we can preload the panel scene. We can use this variable panel scene is equal preload this. So we preload the scene of panel, and then we can initial each panel in Sudoku. So we define the init grid function, and in this function, in this init grid function, and we can add the panel to this scene. So for I in row, for J in column, and we can instance a node like this, panel scene dot instance, and then we can set the panel's position. So we can define some variable. First, I define the offset x is 0 and offset y is 0. And for each row, we can set offset x is to 0 and the offset y is add 2, and for each column we can add the offset x is add 2, and then we can set the panel rect position to vector, and the size of the panel, and the for J column, and the size, and we can add the offset. And then we can add to the main scene. So we use add child to add this panel node to the main scene. And then we can save and run this scene, and we can see each grid is placed, and but we can set the border more clear. We can add some code. We can have a change. So for each row we can write if I like this, if we can and for each column we can use and we can add this code to set the border like this. You can see the border is larger. So now we finish the grid init, and then I want to fill numbers to this grid. So we can define the array to store the numbers. We define the array, and then we can set init array, and then we can append numbers to this array. For I in row, for J in column, we can append null. We can append null to the array. So now this array has 81 members, and then we can show these numbers. We can define the show function, and first we can get the all panel nodes, and we can use get children function to get all the panel nodes, and then we can get the number in array. So we can get a number is we can use a loop for I in row, for J in column, and we can get a number use I use this index to get the number in array. Number is equal to the index of this array, and then we can judge if this number exists. We can show it. So we can also show. We can set this panel. We can find this panel node and get the label. Get label node and set the text to this number. And now we can show all the numbers. I can random set some number. So you can see I set the 4 numbers in array, and then I show this number. Okay, and then I'm going to fill all numbers in this grid. So I define a function called fill numbers, and in this function I will fill all numbers in Sudoku. So and my strategy is, first of all, I'm going to fill this area, fill 1 to 9, this top left area. So I can write for I in 3, for j in 3, and I can define a temporary variable, temporary array, to store 1 to 9 number. And then I use the shuffle function to set this number randomly, and then I can use this to set number, and use pop back to set this number. And you can see, I want to call this function. So in ready, I call this fill numbers, and then we have a loop. You can see that this area is filled with number, and then I'm going to fill the middle area, and the bottom right area is as the same as this top left area. So we can add a loop for n in 3, and we can have a change. So this is range, and then this is same range, and so we can see now I filled 3 areas of Sudoku like this. Use this function, and then I'm going to fill other empty grids with number. And my strategy is, for example, for this grid, I calculate the candidates, which number is the candidate of this grid. For example, it cannot be these 3 numbers because it's the same row. So, and also we can judge the column, which number is cannot fill in this grid. So so I can define some functions. First, I can define get row numbers, and I can give it a argument get row numbers. I can get which row should we get numbers. So for j in column, and we can define a array called result. And if this grid has number, so we can that's right. We can get this number. One number is and then if this number exists, we can append to the result, and then we can return this result. This function is used to get the row number in which row we want to get, and then the same is we can get the column numbers in which column. Also is as same as this, but we have changed. And now we can get the row numbers and get column numbers. And then I want to calculate the area. How many numbers in each area has. So I define function called get area numbers, and I want to give two arguments. Is which row and which column, and then we can calculate the offset row is equals to this row, and it's like this. We can get the area offset row and the offset column like this. We can print it. Let's have a test. We can get area numbers for the first top left area. So it will print 0 and 0. So let's have a look. For the first area, the offset row is 0, 0, and we can test the top middle area, like maybe 3 or 4. Is 0, 1, 2, 3. Oh, there's something wrong. So This print is offset I and offset J. So we can see this area offset row and offset column is 0 and 3, and for this area we can test like this, and it will print 0 and 6 like this. So and then we can get all the numbers it contains. So for area I in range offset I to offset I at 3, and for area J in range offset J to offset J and add 3, and we can get a number. Use this, and then we can judge if this number exists. We can append to result and then return. So we can test. For the first area, it will print all the numbers. So we can see for the first area, we can see there's something wrong. 742. Oh, this is area. Okay, this. And then we can see we get the area numbers for the first area. It will print all the numbers. And we test this area like 5, and I can add some numbers. Oh. Three, four, five. Oh, this is 5. We can add. You can see I fill 3 numbers, and the result is return 3 numbers. So now I define these 3 functions to get the row numbers and get the column numbers and get the area numbers. And then for now I can judge which each grid should have candidates. So I define a function called get candidates, and it uses 2 arguments. And I can define a temp array to store all candidates. And and for numbers, in get row numbers, we can erase this number. And also for number in get column number, we can use J column. We can also erase this number. And also for number in get area numbers, we can also erase it. And now we can return the candidates. And let's test. So in this field numbers function, I add get candidates like this grid. So you can see in this grid 0, 3, and get candidates is 4 numbers. Is this grid. So I can use a recursion to fill all other empty grids. So I can define a recursion function, so call fill empty. And in this recursion function, fill empty, I'm trying to fill a candidate. So first we can find the empty grid. So we can define the find none is array dot find none. And if we cannot find the empty grid, so we can return true. It means it's full. This all the grid is full. And then we can calculate this grid. We can calculate the I and j. We can calculate by this find is like this. So we can get the empty grid in which row and column. So we can test I and j. So we can see we will get the first empty grid in this place. So it's I is 0 and j is 3. So and if I fill it, it will get 0, 4 grid. And then I am going to set this grid. So I can get candidates using get function, and we can judge if it has candidates. If it has not candidates, so it will return false. And if it has candidates, if this grid has candidates, we can fill it. So we can define the fill variable, and then we can set this this grid to fill this number. So we can see uh, fill empty void return true candidate. We can print this candidate and see it has fill. We can fill the candidate dot pop back, and so you can see it will fill with 9. So you can see this grid is fill the first candidate, number 9, and then next grid will also we can use recursion function. So we can call this function again. So we can set fill empty. So we can see while we use recursion, it will fill this 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. This 11 number can use the first candidate to fill, and but to this grid it doesn't have the candidates, so it will stop. So we want to go back. When it returns false, we will clean this field number and go back and try the other candidates to continue to fill other empty grids. So let's change it. So we can set we can write while candidate while this grid have candidates, we can pop a candidate to fill, and if it can continue to fill next grid, if it can continue to fill next grid, we can return true. But if when the case is cannot fill the next grid, we should clean the number we fill and continue to try next candidate. So if it can fill, we return true, and if it cannot fill, so we will clean this to null, and if cannot fill the next grid, it will clean itself and try to choose the other candidates until all the grid is filled, is returned true. It will stop. So we can see the result. So you can see the grid is filled. We can get the full Sudoku puzzle. And now I'm going to clean clean some numbers. So now let's try to clean some numbers. So when we fill all numbers, we can clean some numbers. So I define the function called clean numbers, and then I define this function clean numbers. This this function is likely for each grid, for I in row and for j in column. For each grid, if this grid, you can see for this grid, if this grid doesn't have the candidates, we can remove it. You can see. So if candidate is get candidate I and j, if candidate is empty, so we can clean it. That's all. You can see it will choose each grid and judge if this grid if it doesn't have candidates, so you can clean it, and it will remain the grid that cannot have other candidates. It cannot remove it. So that's my code to generate the Sudoku puzzle. Thanks for watching.